flipped classroom techniques in a course for mathematics for engineering students, a first-year course. And previously, this course had involved some large lectures, 2 or 3 or sometimes 400 students all at once, meeting twice a week. And we noticed that there was particularly low engagement, especially as the course went on. In these large lecture theaters, the students felt anonymous and they weren't very incentivized to really engage with the learning activities. So what we wanted to do is we wanted to move the aspects of the lecture that didn't really involve any interaction into an online environment. So what we flipped in this case was the kind of fact aspect of the lectures. We flipped nearly all of the lectures onto videos. There were still a few face-to-face lectures that the students get, so they get to get together and they get to see one person for 3 or 4 different lectures. But for the most part, the material, the sort of base course material, is now in videos online, and the face-to-face component focuses more on a kind of active engagement, a participation between the students and the teachers, so they get to try to solve problems and think about how to use the things they've been learning rather than spending that time just being told, here's a fact. In our case, the goal wasn't so much to save time as to allow us to interact more with the students. So in the previous incarnation of our course, where we had a large lecture, most of the time spent where the students and the teachers were in the same room. There would be the teacher talking, explaining some technique to the students. But what we wanted to do is we wanted to make this more active. In my lectures in this course, I had noticed that if you introduced some activities, if you said, here's a problem, I'll solve an example, and then now you solve one, if we introduced these, the students were much more interested in the learning activities. And so what we wanted to do was we wanted to bring more of that active style of learning into the teaching environment, into the classroom, so that the students could really get the benefit of interacting with someone who understood the techniques at a really deep level. So for us, this wasn't about saving time, and in fact, we took these large lectures, 200, 300, or 400 students, and we wanted to break them up into much smaller classes of, say, 30, 35 students, and give them a lot of individual attention. So in this case, it wasn't about saving time, it was about improving the teaching experience and really getting the students to involve themselves and engage with the material.
Our main hope for the class time was to increase interaction between students and the teaching staff, and also between the students themselves with each other. So the activities we designed were done with that in mind. So our plan was the class would start with the tutor giving a recap of the material that students had seen in the videos, just a brief recap to get their minds in gear. And then we'd move on to an example done at the board, the idea being that the students would contribute some of the steps in the working, and it would increase sort of discussion between the tutoring staff and the students. And then we'd move on to problems for the students to work on, which would involve hopefully small discussions amongst the students working in groups of 2, 3 or 4. And the plan was that we'd design questions that would be harder than the standard questions that students would be expected to do on their own. And this way we'd encourage them to talk to each other, bring up interesting points, rather than just working in isolation. We were able to monitor the student engagement with our flipped content, videos, followed by online tests, because rather than just giving students links to a YouTube clip, which we'd ask them to watch, instead we developed an online environment where students had to log in. They were given a login. Once they logged in, it presented them with the videos they needed to watch, and then each video was followed by an online test. Now, we couldn't completely discount the possibility that students would leave these videos running and walk away from their computer and come back when it was finished. But we did ensure that students couldn't fast forward the video by just pointing through the timeline. So in that way, we hope that the figures we had on the number of students who'd accessed the videos and the online tests corresponded to the number of students who had properly watched the content before their classes. We used an online environment for our flipped teaching, which was something we developed in the department ourselves. It's a system called Assessment in Mathematics, or AIM for short. Now, this was originally developed as an online testing system for mathematical questions, where it could set algebraic questions and then understand different rearrangements of the same answer, things like that. And we adapted that so that each test could be preceded by a video instead of just being an online test. Now, this was really useful. It was a nice streamlined system where students could log in quickly, get to the videos quickly, and then be asked maths tests in a sophisticated way. But there are plenty of other online environments that we could have used. I think it was important that we did use an online environment rather than just sending links to clips, as I think it made a more integrated experience for the student.
There were a lot of people that were involved in the process of creating the flipped content for this new course. Previously, there would be one or two or maybe up to 3 lecturers doing the primary lecturing for these large engineering courses, and then there would be another handful of teaching staff running some tutorials once a week to answer questions that the students might have. When we went through the design process, there were about 5 of us who were involved in a working group to try to hammer out the details of how we wanted to organize the flipped content. This also involves some liaising, since this was a mathematics course, but it was for engineering students, so we had to discuss this with various staff in the different engineering departments that we would be servicing. Then we had to make all of the videos that would go along with the course. In this case, it's a year-long course, and there were 8 of us that made videos for the content that would replace the lectures. There's also an online testing system that goes along with these videos to ensure that the students are interacting and actually watching the videos. So there's another person involved in that. And then now, once we've implemented the course, we have these smaller class sizes, and that means we actually have more people doing teaching, but what they don't have is they don't have a standard lecture. Instead, they have a much more active kind of teaching experience where the students have some problems to solve, and they really get to discuss those problems with the students on an individual basis.
We think switching to the flip mode of teaching actually was a slight increase in resources on our teaching staff. Now, it was quite difficult to measure the difference or to give a clear comparison between what we used to do and what we did now. I mean, it was clear how much teaching was being done in the new version of the course. We split students into groups of 40, and each group had a tutor which they saw twice a week. So it was easy to get an idea of that kind of teaching time. Difficulty was, in the past, we had a slightly different setup with some fully qualified lecturers and some PhD students working in groups of varying sizes, and although we had a sort of an idea of the ratio of total number of staff to students, how much of that was sort of lecturing staff and how much was PhD student wasn't clear. But our best estimates is that we've slightly increased resources, but not by a whole load. And then the interesting thing was, as we introduced more and more students to this way of teaching, we're now up to 1,000 students being taught in this way, we did start to see economies of scale in terms of people being involved in the running of modules. A bit less time spent on the sort of administrative side of organising a course. That's where you get the efficiencies. And in fact, we also introduced a course administrator, a member of the administrative staff, to answer routine emails from students, taking that burden away from the lecturing staff. really encouraging thing was that students responded really well to this flipped style of teaching. Now these were new first year students, so they hadn't been taught very many formal lecture courses anyway, so in some sense maybe it was natural that they would accept this as a teaching style. But the thing that we spotted quite quickly was that tutors found firstly really good attendance at their classes, which hadn't always been the case. In fact, it was one of the problems we were trying to address in introducing this flipped style. But not only were the students attending, they were working really well. We didn't have to spend much time encouraging them to get started on their work, encouraging them to think about things. It seemed that something about the way we were teaching this material meant that they were engaging better than they had before.
We decided to introduce some flipped content for this course primarily because of a feeling that the teaching that we were doing in this course was not as good as it could have been. There were very large lectures, and these lectures, it was fairly clear that the students were not excited about sitting in a large lecture theater and just listening to someone talk to them. I had been introducing more and more of an active component in these large lectures, and the students were much more excited to do the problems and then get a bit of feedback from me directly than they were to listen to me try to explain how the problems were supposed to be solved. So we wanted to focus on that aspect. We also had tutorials every week, so the students would have some homework problems that they would be assigned, and they could go to the tutorial session and ask their tutor for help. These would often still have maybe 80 or 90 students per tutorial session to maybe only 1 to 3 teaching staff. And it was fairly clear as the semester went on that attendance would drop fairly substantially, sometimes to 25%, maybe even 10% of the number of students that were assigned to that tutorial section. So they weren't really getting value out of the teaching time we were spending. And our goal was to really change that, to really introduce some exciting teaching and get the students to engage with the course material. We had expectations of kind of 2 varieties going into making these changes. The first was that we expected that the learning environment would be much more interesting and exciting for both the staff doing the teaching in the smaller classes and for the students that were going to those classes. We expected the students to be much more interested when they could really have that personal interaction with the teachers that were present instead of the sort of anonymous feeling you get in a very large lecture. We also hoped, but did not necessarily expect, that this would lead to specifically better performance on exams. This was not the primary focus of making these changes and introducing the flipped content, but we did hope that as students engaged more with the material, that they would find that their exam performance naturally improved. And this did turn out to be the case. But primarily, the goal really was to make that teaching experience much, much higher quality. The most difficult thing to consider during the design process for introducing this flipped content was really the flipping itself. This was the first time that anyone in our department had used an online component to this degree, giving essentially all of the basic lecture material through videos and then supporting it in this particular fashion. So there was a lot of concern that maybe students wouldn't want to watch the videos that we had created and that they would show up to these more intimate classrooms not really having any idea what was going on. Another concern was that they would watch the videos, and there's a short quiz at the end of each video that the students have to take that is part of their assessment, but there was also serious concern that maybe students wouldn't really watch the video, they would just turn it on and play it, and they would get someone else to fill in the quiz for them at the end. So in essence, just kind of skipping the video component and not really learning anything. These were some of the main concerns we had going in, since we didn't have any experience, any hands-on experience with this kind of technique. But it turned out that everything worked essentially as we intended it to. The students did watch the videos, and by and large they did complete the quizzes, and they would show up to the classroom already as prepared as we intended them to be, and ready to really work on solving the problems that's the sort of meat of the course.
The course actually ran very smoothly on the first go. That said, the main challenge was that there was lots of new material that was being used, completely new worksheets for the classes, the videos themselves, the online tests. So there were lots of things where there could be typos or errors that we hadn't spotted when we first made them. In terms of running the course, I think it was a challenge to keep on top of releasing all the new material in the right way, and we had to reinforce the message to students of what was expected from them. We didn't take the risk of not doing that to see what would happen, so we did send out a lot of emails just saying, remember, new tests have been released today, make sure you watch them before your next class, and so on. And in addition, there were new teaching staff, the teaching staff were new to this way of teaching. So there was a fair bit of effort involved in making sure they knew what was expected of them and asking them for feedback on how well it was working and stuff like that.
We had two kinds of evidence that this sort of technique would enhance the learning that was going on in this course. The first is that I'd done some reading about using online components, and it seemed like there was a wide variety of success stories in using some online components in a kind of traditional lecture style course. And that really it was down to good implementation and good planning. And I felt confident that we could do that we could put together good material that the students would engage with. And the second was our personal experience dealing with the students in these specific courses. They seemed very excited to put their understanding of techniques to the test. They really liked solving problems and being asked questions. Often they enjoyed the harder, more challenging questions, as well as just going through and sort of solving things to know that they had the basic technique down. So we had seen that the students were interested in doing a more active style of learning. This was fairly clear all throughout my experience lecturing these students. And so we were certain that if we could focus the teaching experience on this active style of learning, that the students would really respond and engage strongly with the course.
The main data that we had that pointed to a need to change our course was the attendance data from the classes. So previously to the change, we'd seen classes where they'd start the semester fairly full, 90% attendance, but as the semester went on, this attendance would drop away. By the end of the semester, we were down to sometimes as low as 40%. Now this wasn't great, we knew it wasn't great, but we didn't seem to be able to stop it. We'd chase students up by email, and we'd try our best to make the classes as interesting as possible. But on top of that attendance data, the message coming through on questionnaires was that students didn't find these classes particularly useful. So there was something about the classes themselves where students thought, I don't get much from attending this class. And so what did that point to? Well, it pointed to something that would make the classes more of a priority, more engaging, more important to the students. And I think that's what we achieved by this flipped approach.
I had read some literature on using online components in teaching in a variety of forms, but what we hadn't actually done is identified the sort of specific format that we were going to use while I was doing this literature review. And the specific way in which we use some flipped content together with what the class itself would consist of, we never actually found any literature on this kind of specific combination in the context of a sort of mathematics course. There was a lot of literature about other science courses and involving some online components together with some traditional components, but nothing that was specifically germane to what we were doing. We looked at some literature, but we actually hadn't looked at any literature which specifically discussed a flipped approach of the kind that we were interested in implementing. So while the literature that we had read was useful in getting an understanding of how you could introduce some online components and what sort of support might be necessary, there wasn't anything that gave us a specific kind of strategy that we could then model our course on. This is a result of some research, but also a lot of discussion as to how we could take the teaching that we wanted to do and really put that into practice. None of the people that were involved in the design or the implementation of this course, to my knowledge, have any specific training on a flipped classroom approach. We do have some background in other somewhat similar teaching techniques. So for example, we have videos that have lecture material, and then there are online quizzes after those videos that the students have to complete. A number of the people involved in the design and implementation of this course have a lot of background in designing both the software and the particular tests that we needed to adequately kind of ask the students questions about the videos, to test them, to make sure that they are really paying attention and actually trying to do some learning while they're watching these videos. So that's one aspect that we had some prior experience with. And another is that there are other sort of interactive teaching approaches. For example, the Moore method is one commonly used in mathematics that some of us had had experience with in the past. And this is the kind of thing that we wanted to introduce in the classroom components of the course. So they weren't just going to be lectures, but they were going to be active learning in which the students and the teachers are talking to each other and making progress together. We did have some experience with that aspect as well.
Initially, we didn't tell students that this new flipped approach was indeed a new approach. Of course, these were first-year students who were new to university, and we just told them very clearly in the first lecture for the course how it was going to run. We didn't say it was new, we didn't explain why we were doing it this way. Later on in the course, by halfway through the first semester, when we were pretty sure it was working nicely anyway, we did tell them then that this was a new approach and that we would welcome feedback, and we gave them a little bit of an explanation as to why we were doing it this way. But initially we didn't feel the need to do that, or worried that doing that might actually make the students a bit hesitant about it. So we just confidently presented the way we expected the course to run, and students accepted that. The reaction of the students at the end was overwhelmingly positive. We got questionnaires from the students at the end of each semester, and the main features were that 92% of them were satisfied or very satisfied with the course, which was great. And in addition, we had free text comments from them where we asked questions like, what was good about this module? And there we found responses like some quotes were people saying, everything, I love this style of teaching. Somebody else said that the videos deeply helped their understanding of the material. People talked about the freedom in learning that they had and how the videos were an invaluable resource. So that was really positive. In addition, we found that 2/3 of those who responded to the question what was good about this module said the video lectures somewhere in their response. And that was quite a lot of responses. I think maybe 170 people responded, and 2/3 of those had said they liked the video lectures. And then another piece of evidence in favour was that when asked what could be done to improve the module, while there were lots of suggestions for tweaks to the system, there was no overriding message of something that was wrong. And in fact, only 5 of the responses from these 240 students said that they would prefer standard lectures to the video lectures. So I think it was pretty clear from this questionnaire that the students loved this style of teaching, and it was definitely a step forward.
Based on our initial planning, as well as feedback that we've gotten from the students after running this flipped course, it's clear that the benefits we'd anticipated in moving to a more active style of teaching, where the students are really the drivers, where they've been given problems but they can really talk to their peers and talk to the teacher, that is something that has given them benefits. They enjoy the experience much more, the teachers enjoy the experience much more, and it's fairly clear that this has been successful in promoting the kind of learning environment that we were interested in introducing in the first place.
Overall, I think we're pretty clear that this has been a major step forward for the teaching of this course, and that it was a big success. I mean, firstly, we had the student reaction, which was overwhelmingly positive. We also had exam data that we could analyse, and we were able to do proper statistical analysis of this, comparing it with exam data from the 3 years previously. And what we found, where we controlled for differences amongst the students, differences in the difficulty of the exams, we found that we'd added something like 5 marks to the average grade of a student, which is quite a big increase. I mean, that's half of a degree class, if you like. So that was a really positive thing. But even if you don't believe the exam data that we had, we saw engagement significantly improved. I mean, the attendance was much better throughout the year. And in fact, because the attendance was higher and we were asking students to go to twice as many classes, what we found was that over the year, students had attended something like 3 times more classes of these small problem classes than they used to. Now, our belief is that that's where the students really benefit from interaction with staff. That's really where they're going to do most of their learning. So the fact that they were attending 3 times as many sessions of that form, I think speaks for itself.
Of introducing a flipped classroom into our course for Mathematics for Engineering students has been very positive. This has taught me and many of the other teaching staff here a lot about how to introduce new components into our teaching, and it's given us hands-on experience with things like using videos for lecture content as well as using an online testing system. I think this has been a really valuable learning experience for many of us into just thinking about how different teaching components can interact and how they can serve particular purposes when you're trying to design learning activities and when you think about the environment in which those are taking place. It's also clear that setting up a flipped classroom method really does take a lot of effort. It took a lot of us time in the design phase, and then in the sort of post-design, pre-implementation phase where we were designing the specifics of the videos and the classroom material and writing the online tests. And then also in the implementation, in our case, we were taking a very large lecture and breaking it up into a lot of smaller, more intimate classroom experiences. And that means there is more time spent for us at this point than there used to be in face-to-face teaching, but the payoff is that we have much higher quality teaching and the students are really getting a lot more out of this. So there is definitely space for really good flipped classroom teaching, but it has to be designed well, it has to be thought through, and it's worth taking the time and putting forth the effort at the very beginning to ensure that students and teachers get a really positive experience in the class itself.
If I were to give advice to someone thinking of flipping, my main point would be to be brave and go for it. I think to get a big change in how students are interacting or student performance, you need to do something big. So tweaking around the edges, well, it can get you small improvements, but to get a big change, you need to be bold and try something radical. So that's my first bit of advice. The second thing to say is that technology now opens new possibilities. I mean, we've developed a model that works well for our course, but there are plenty of other bits of software or ideas involving new technology that we could have thought about, and we could have come up with a different model that would have possibly worked even better. And the final thing is, don't be worried about students rejecting your approach. I think if you get the details right in what you expect of them, and you make clear what's expected from them, and you think about what the experience would be like from their point of view, then I think they are open-minded and will accept pretty much anything you throw at them.